Good afternoon and good day to everybody who is going to be joining this live stream episode. We are back once again, once more for everybody. Welcome one and welcome all to one more episode of Baji in Physics, where we will talk about some cosmology, physics, astrophysics, astronomy type of topics. We have been covering some very interesting topics recently, answering your questions, taking any questions and discussing the topics. And we have also been actually referencing a book by Neil deGrasse Tyson, and we will continue with that tonight in today's episode. So last night we had a lot of fun doing that, and we will continue that tonight as well. And I've named this episode Cosmic Girl because somebody in the live last night actually called me that, and they said, oh, there is the Cosmic Girl. So I really liked that comment, whoever that was, and feel free to come if you're coming to the live, put a chat message so I can know who you are again tonight. And as always, please do like, share, and subscribe. Let me make sure that all of the buttons are buttoning with the live. And I will share the live soon here. I actually made myself some hot chocolate, which is, of course, in the microwave from a Swiss Miss. In fact, I am now all done with my can of Swiss Miss. So I'm going to go get the mug. It was too hot to touch before I started the live. And I was setting things up. I am using a very thick book to put the camera on top of the on that book using my phone stand. So thank you so much. Hello, Daniel. Oh, I've seen you before. Daniel Amaga Lanes 8911 is here saying greetings from Houston. Well, welcome, Houston. Welcome all my continents. Hello, Key1. Hello, Key147. Everybody, thank you so much for joining. If you're seeing this live, we are live. We are live. Baji in Physics. We are live. If you're seeing this later on as a video upload, once the live gets posted, then please do leave us a comment if you missed out on the chat by being live here. I always love to read all your comments later on as well. But if you're here and you're here with us now, then certainly put something in the chat so I can say hi to you. Hello, Daniel. It's nice being with you. Oh, thank you. Well, thank you so much. Please do like, share, and subscribe. Please do double tap the screen and give us some likes, some emojis, some hearts, some love. Really appreciate it. I will be sharing the live and putting that in the chat as well. I hope that some of my mods will join and can help out with that. Thank you, everybody. Thank you for joining. Like, share, subscribe, please. Thank you so much. We will be starting our topic very soon here after I say hi to people. Where are you from? Hello, Key1. Mr. Handsome 95 is saying hi. Hello. Handsome 95. Were you born in 95, Handsome? Daniel is saying, I'll be here with you. Matthew is saying, we went to school together. Oh, did we? Hello, Matthew Kimball. We went to school together. Where did we go to school together? And thank you for bringing that to my attention. Key1 is saying, what topic? We will be, let me actually show you the book. We will be covering something from this book that we have started last night. It is called Death by a Black Hole by none other than Neil deGrasse Tyson. Thank you for liking the live, guys. Thank you so much. Hello, Taj. Matthew said we went to school together. Just kidding. Hello, my heart. How are you? Hello, Taj. I will support you. Well, thank you so much. Sky Nels is saying Mumbai. Hello, Mumbai. Tommy is saying, I would love nothing more than to be... I see. I thought you were asking to be a mod, actually. Like, I thought you wanted to be the chair of one of the chairs of this live. I see. Well, Tommy, you might want to behave once the mods are here. They're currently not here. I don't see them anyways. Let's see. Miguel is, oh gosh. Hello, Miguel. Hello, Kiwan. Hello, Rubble. Have you tried the new Dixon cider? I don't know what that is, but thank you. Hello, gorgeous goddess. Well, thank you so much, Ranger. I have this hairband on and People do sometimes call me a goddess when I wear it. Well, thank you so much. Indeed, I actually just got done reading that. I was so excited to talk about it. I interrupted my dad watching football. He got so mad that I interrupted the game. Oh, hello, Mr. Baseball. We can certainly, you can, this is the correct spot to talk all you want about that book or anything cosmology, physics, astronomy, or astrophysics. We will be discussing that right here, right now. Sometimes I have Baji on the cat tree behind me. Currently, he is doing something else. He's preoccupied, but he might just be joining our classes here, our discussions here. We are just getting started now. Hello, Ben Tipton. How are you doing? Hello, Taz. What we on today? We are going to be doing some physics discussions today. Astrophysics, indeed. I'm going to knock on your door and ask for some peach cobbler. Please don't do that. That would freak me out. Hello, Willie. Hello, Snow Leopard. Hello, Imposter. Hi, you're so pretty. Thank you so much. Well, I appreciate you. Bonjour. Teal Mushroom. Parviz is saying, how are you? Miguel is saying, geez, are you taking volunteers to be your chair? I'm not. Hello, Robble Skin. Hello, that guy. Hello, Snapshot. Hello, Miguel. Hello, Eli. Holy, you're so pretty. Well, thank you. Thank you. Thank you. Parviz is saying, okay. Hello, Lord Have Mercy. Hello, cute like a little mouse. Who? There is no mouse here, at least I hope anyways. Thank you, Snow Leopard, for sending the gift. Bend over. Cosmetology. Indeed, we will be talking about cosmology, not cosmetology, even though the two can get mixed up. What about quantum? We can talk about quantum too. Tommy is saying something about Gabe. I don't know what that is. Hello, Willie. Do you like plate tectonics, physics, and chemistry? What are we talking? So, plate tectonics. We haven't actually talked too much about plate tectonics. I do have a playlist called, I'm trying to remember. I think I just called it Planets and Astronomy playlist. I do have a playlist on just the planets of our solar system and more. And so if you're interested, then I do have a playlist on the planets. But generally we talk more about astrophysics and cosmology and astronomy that is beyond the solar system. But thank you for asking. I love astrophysicist. Hello, yours truly, Todd. Thank you for the gifts, guys. Really appreciate you. Really appreciate all the support that you're showing through the gifts because that does help a lot with this channel. Thank you so much. Hello, Snapshot. Hello, Willie Boogie. Hello, Stonegate. Good, you're not a fake card reader. Some people have asked if I'm a tarot card reader. Indeed, I am not. At least not on this channel anyways. Maybe I should make a separate channel for that since that seems to be such in demand. Willie is saying I was being silly. I'm not serious. Okay. Sage Diamond is saying not gonna lie, flaunting brains. That's a hook. Hello, Snow Leopard. Thank you for sending the floating heart. Really appreciate you. Joshua. Hello, Joshua. Here I am. I stand at the door and knock. Well, okay. Thank you, Willie. So what about Atlas? Hello from New York. Hello from New York. The NASA narrative. Can you speak Chinese? I really indeed cannot. Unfortunately, I asked lots of people about peach cobbler. Okay. Thank you, Occupavi, for sending the flower. Hello, Fubar Strikes. Your skin is beautiful and bright. Oh, thank you. Thank you, Rayshawn Manning. Impact theory, Sage Diamond is asking about. Could you clarify? What do you mean by that? Thank you so much. Thank you, Snow Leopard. Appreciate the gifts. How did you get interested about the solar system? So I have a PhD in particle astrophysics. So the PhD is in physics, but the subtopic that I focused on for my thesis is particle astrophysics. And I also spent sometime in cosmology and nuclear astrophysics. So that's my background, and I actually did not cover a lot of the solar system when I was in school myself. So like all the details of the planets, the sun, and things like that. So when I got started with the lives here for over a year now, I've been doing these lives mainly focused on the physics topics and covering, astrophysics, cosmology, things like that, and kitty cats, of course. It's a cat plus physics channel. I basically saw that there was some interest with the planets, and I myself wanted to learn more about the planets because I did not know too much details about our own planets in our own solar system, because that was never a focus for me, like something that's more of a geophysics topic, or because the rocky planets are so different from the from like the Jovian planets, for example, right? Things like that. But recently also I felt very inspired in the sense that not even like, it's more like fascinated, inspiration and fascination both, because this whole situation with stars dying, making gas nebula or gas clouds, and then those eventually getting cold enough to condensate into something that then gets hot enough to make a star and its planets. This whole situation also got me very fascinated. Indeed, we actually read about that a little bit last night in a more general sense, and it connected back to our discussion when we did those planet lives. So there was a number of lives sort of happening chronologically some months ago, where every day I was covering something with the planets. And so that's why I point you to the planets playlist that I have. I have a few playlists, and one of them is the planets playlist. I think I call it planets. Let me just check and tell you, because I have forgotten exactly what I call it. Okay. So let us see now. Oh, by the way, please do like, share, and subscribe, my darlings, because it helps me out, and it helps to grow and build this channel. Thank you so very much. And even if you disagree with anything, I love to hear it. Last night, we even talked about God and religion, and somebody actually told me about Moses, because I didn't know much about Moses. So it's a safe space for everyone, I would hope, unless you're trying to hurt somebody, which I hope you're not. Okay, so I put in the chat, like and subscribe. Please tell your neighbors, sisters, brothers, cousins, family members, and friends and enemies about the channel. Much appreciate all your help with that. Really do very much appreciate it, to get the word out and whatnot. So let's see. I'm gonna say that we are live. We are alive indeed. Please do join us. PhD in physics. Hello, NYC Durrani. I do have a PhD in physics, exactly, with the subtopic of my thesis ended up being in particle astro. Hello, Elijah is saying hi, doctor. Hello, Hoi Sung Choi is saying you cute. Okay, I know I'm always about the solution and not necessarily the problem. Gang, fully procreative with history. Feel dumb compared to that. Hello, Joseph. What languages can you speak? That's a great question. Hello, Jess, hers, Chell. I can speak English, Bangla, that is Bengali, Hindi, and a bit of Urdu. Urdu is similar to Hindi. I cannot read Urdu though. The other ones I can read, write, understand, speak, and all that. Hindi, I am out of touch with, but Bengali, Bangla is my native tongue, and English is also basically a language I grew up with. So, okay, Josh B, and I know a few words of Spanish. I really should know more, because I get mistaken a lot for being able to speak Spanish, and I don't feel good about letting those people down that think I should know more Spanish. So I'm always excited to learn more. If you want to say something to me in Spanish, please do. And teach me anything you want, actually. Spanish, Italian, German, Afrikaan, anything. Thank you, Michael. Oh, thank you. Michael is saying I'm going to donate. Well, thank you, everybody. Oh, thank you so much. Michael has sent gifts. Thank you very much. Appreciated. All the support on YouTube. I also have a PayPal in the link in my description in case that's what you meant. But I see your thing. User says, Will Green LV, I love you. Oh, thank you, thank you. Talk about gravitational waves. Okay, that's a great topic. Yours truly, Todd. The planets, do you agree with Avi Loeb and his theories of extraterrestrial life? How do black holes in space work? Is this your date of birth? Hello, Pranay. It would be great if you didn't ask me my personal information. I do believe that that's actually kind of illegal on YouTube. We should not be sharing our personal information. So thank you so much for not doing that for yourself or me. Willie is saying supernova. Everin is saying Owendry. Hello. I like the all caps. Pluto will always be a planet to me. Hello. Oh, Lord Byron. Oh my goodness. Well, Lord Byron is here. We promised him a poem from Byron at some point. I don't have it with me tonight, but I will keep it in mind. Do you believe that nothing can create something? Yes. Because nothing is generally not nothing. So I'll real quick say that. In our experience of the cosmos, at least, we tend to find that nothing is generally not nothing. It can actually have lots of things happening and going in and out of existence. And there can be particles that are annihilating with their anti-particle partners and things like that. So be careful about nothing and understanding there might be something deeper there when we say nothing, okay? Hello, Reshan. It's basically, I don't remember Arabian Nights. Good God. Hello. Hello, Stay Clever. Favorite Bible verse. You should write it here for us because I don't know any too well because I did not grow up with the Bible. But you should share one. How about that? Hello, Willie. Hello, AJ. No earrings. Uh-huh. He cracked the sea. Thank you, AJ, for the marshmallow. Miguel is asking, what are you going to do for Christmas? Earth tilts every so... The Earth has a tilt. Are you asking for the tilt of the Earth, the fact that it's tilted on the axis, on its rotational axis, the 23.5 degrees tilt? Because that it has, and if I remember correctly, Mars has a similar one, a similar tilt. If we talk about that, then I have my book ready for that. Yours truly is saying, I like your positivity. Oh, thank you. Your idea is 4 gigs. Mine is just 1 gig. Okay. Hello, SH Tark. Are you a proponent of string theory? Asking, Lord Byron is asking. Thank you. Thank you so much for scrolling and finding me. Please do like, share, and subscribe, my darlings. Let me get my hot chocolate. It's going to get very cold if I don't start sipping it. 1 second, please. And this is very nice that people are asking questions and engaging. There is Baji Baba, and here is the book, by the way. And I will be right back with the chocolate. Don't go anywhere. Okay, so, all right, here I come. Here I come with the chocolate. With the chocolate. Let's see. Okay, so did I say to like, share, and subscribe? Please do that. Ow! Almost fell in my hot chocolate. Thank you everybody for liking, sharing, and subscribing, my darling friends who have joined. Can I message you on WhatsApp? So by the way, I just wanted to make a quick announcement because this has been happening more frequently lately. You could indeed message me on Instagram, Facebook, all those other social media accounts that I have linked to this channel. But unfortunately, I mainly use the social media public accounts and profiles for business, for like, you know, this sort of content stuff. I'm not sure if I'll be able to respond in a personal fashion to you guys when you ask personal questions, okay? So do keep that in mind, but you're more than welcome to follow and message all you want on all of those accounts that are linked on YouTube, okay? But I am getting quite a lot of messages, and I might not see it right away, and if it's asking a personal question, I might not be able to answer. Okay, what's your middle name? You guys are funny. Okay. So now, with that out of the way, who does your hair? I do my hair. Yours truly. So what I might do is do a bit of reading from the book that I promised I would. It is chocolate, yeah, it's hot chocolate. This video is sponsored by Swiss Miss. Not really, but it should be. Also, I'm out of hot chocolate. So if someone wants to send me hot chocolate, that would indeed be most welcome. Okay. I'm trying to scroll and see if I caught people's messages. Was there anything I missed? Why is your face so shiny and beautiful? Oh, thank you. Well, I went to the gym and I lifted some weights, and I did my swimming, and I did the hot tub and shower and sauna. I think that helped. Thank you, Omar Aziz, for sending the floating heart. Really appreciate it. I hate that there's no brown girls in South New Jersey. Hello, icy icicles. No marshmallows. I don't have marshmallows at the moment. I think I do like Beyonce. I like Beyonce. Yes, I do like Beyonce. I think I like Rihanna more, actually. Thank you, Omar Aziz. I really appreciate you. Much, much appreciate. Ooh, Lord have mercy was saying hi, 333. 333 back to you, my friend. I do like the number 3, 3, and 3. Very much. I like Rihanna, to the person that, I mean, I like Beyonce too. More power to all these women, right? And Rihanna is a billionaire. I do like that she's such a good businesswoman. Hello, Kitty Cat, says Tyler. Hello, Tyler. So, by the way, let me see the top fans and read those. Number 1 is AJ. Wow. Hello, AJ. Number 2 is Snow Leopard. Number 3 is Key One. Number 4 is Jess, her shelf. Number 5 is Andrew. Number 6 is Daniel. Hello, Daniel. Number 7 is Pretty Good Plants. Number 8 is TWC Myers. Number 9 is John Jones. Number 10 is Vic G. Number 11 is Sage Diamond. Number 12 is Psy Guy. Number 13 is Miguel. Number 14 is Snapshot. Now, I set up to 14 because that's how many reps I do of my weights. Especially if the weight is not too heavy. Like, I'm much more of a reps than a heavyweight kind of person. So sometimes when all the weights, when the max weight is taken, I'm quite relieved actually, and I just go like this and this with a small weight. I can do 15s, I think, on each side. 15, 15, 15, 15, like this, shoulder press. And I go till 14 or 15. So the same thing I did with the number of top fans. So yeah. Hello. Baddie alert. Hello, Alex. I love that. Maybe the next live. So whenever I see a comment that I like very much, I'm making that the title of my next live. So yesterday somebody commented Cosmic Girl, and I thought that was an excellent description of myself. And so today's live is called Cosmic Girl. I think tomorrow will be Baddie alert. Fox is saying, you're married. Are you informing me that I'm married? Thank you for letting me know. Fried Rice is saying, are you Indian? Lord Byron has sent happy poop. Thank you, Lord Byron. How about Chapel Rowan? I don't know who that is, but thank you so much. James is saying, do you like holy something? Some say triple numbers are a sign. I agree. I really like 111. I really do like 111 and 333 and 222. Is that oatmeal? No. This is hot chocolate. Adam! I was waiting for you. I haven't started doing my reading yet. Adam, my mod, is here, who really likes the cosmic readings. So you are here now. Good. I have been getting acquainted with people, but I did not start my reading for tonight yet. I waited, hoping that you would be here. Thank you for joining. Hello, Andy. Do you watch anime? I don't watch much of anything these days. I don't watch much. I'll watch a movie or a TV show if a friend is like hanging out and wants me to watch it with them, but I don't even have any streaming services. So yeah, anime is online for kids. I know what anime is, but actually long time ago I used to watch the show Avatar: The Last Airbender, and I liked that show a lot. One of the shows I've liked a lot. Are you religious? I am not religious, but I am spiritual. Adam is saying, glad to be here. Hello, everybody. Please like, share, subscribe. Adam, can you put in the chat to like, share, and subscribe? And now that you're here, you can keep an eye on the chat for me and greet people and say hi to people and things like that. That would be most amazing, and kind of let me know when I look at the chat if I missed anything important, like a question or something, okay? That would be most helpful. Thank you so much. Thank you for being here. Abdel is saying, why you are cute. Why? Vinland Saga. Hello, Randy. Yes, Baji is behind me. See, he is sometimes behind me. Right now he is. Okay, so last night we had a lot of fun talking about the cosmos, and in fact we talked about some color stuff, and we also talked about stars. Okay, and we talked about the very sort of philosophically satisfying chapter called Dust to Dust, and we talked about how we start from dust and we end up as dust. And we mean the solar system, the stars, the new stars are born out of dust, and then those also die and become ultimately dust. Okay? So we covered that last night. And so if you missed it, please do check it out later on under the live tab of the channel. You can find all the episodes posted. Do you think we end up as dust? Yes, we do. We do end up as dust. We come from dust, gas clouds. They're quite enriched sometimes. Like, for example, our solar system came from a pretty nice metal-rich gas cloud or nebula. And I would say we should be thankful because it has given us all these heavier elements, heavier metals like gold, right? So, but then yes, eventually, when the sun dies and supernovas and dies, we will go back to dust. We will go back to being a gas cloud. And then that gas cloud mixed with other things, and depending on how that whole thing progresses, would be the birthplace of a new star. And we talked about these things. There are places in our own galaxy which are considered to be little nurseries of star birth. And they are more active spots where more stars are birthed. In fact, many of them can be birthed together, as in the same time, in different spots of the galaxy, and those are kind of sibling stars, if you will. Okay, so star stuff. Yes. So Adam, you're here, right? Earth will cease to exist, but we have some time because the sun is still very young. Thank you, Abdel. She's gorgeous, not just beautiful. Okay. You remind me of my old English literature professor. Thank you. I actually loved English literature when I was in high school, and I used to be the school's editor and wrote poetry. Okay, perfect. Thank you so much. Yes, if you like the channel, please do come back to the lives whenever we have the lives, and please do like, share, and subscribe. So now we will start our little narration part of the live, okay? Will the mass change? Of what? The sun, or what do you mean? Okay, we finished dust to dust. Now we will do forged in the stars. Not all scientific discoveries are made by lone antisocial researchers. I decided where I want to hold the book. Nor are all discoveries accompanied by media headlines and best-selling books. Some involve many people, span many decades, require complicated mathematics, and are not easily summarized by the press. Such discoveries pass almost unnoticed by the general public. My vote for the most underappreciated discovery of the 20th century is the realization that supernovas, the explosive death throes of high mass stars, so when a star dies and there is an explosion, that is called a supernova, are the primary source for the origin and relative mix of heavy elements in the universe. So, quite literally, every element heavier than hydrogen and helium have been made in the stars and are available to us through stars dying and supernovaing and spewing all of their, not all of their materials, but a lot of their materials into the interstellar spaces, into space around them, that have then gone on to make gas clouds, have then gone on to make the nebulae. That one such nebula is where we come from, our solar system formed from. So that is why I was saying earlier that, if you like a heavier element, well, every one of them, so pick one. Everyone, put your favorite element in the chat and we will say where it comes from, okay? So my vote, so his vote is the supernova leading to giving us all the heavier elements. That is the discovery that we made in the 20th century that he likes a lot. This unheralded discovery took the form of an extensive research paper published in 1957 in the journal Reviews of Modern Physics, titled The Synthesis of the Elements in Stars by E. Margaret Burbidge, Geoffrey Burbidge, William Fowler, and Fred Hoyle. In the paper, they built a theoretical and computational framework that freshly interpreted 40 years of musings by others on such hot topics as the sources of stellar energy and the transmutation of elements. Carbon is a good one because we rely on it for life a lot. We have a lot of carbon in us, and yes, carbon is also made in stars. You have to be a bigger star in mass than the sun to make carbon. I hope that we see Betelgeuse supernova, and Betelgeuse is spelled as Betelgeuse, okay? Not like the Beetlejuice, like fruit juice. Thank you, everybody. Love your comments. So, cosmic nuclear chemistry is a messy business. It was messy in 1957 and it is messy now. The relevant questions have always included how do the various elements from the famed periodic table of elements behave when subjected to assorted temperatures and pressures? Do the elements fuse or do they split? How easily is this accomplished? Does the process liberate or absorb energy? The periodic table is, of course, much more than just a mysterious chart of 100 or so boxes with cryptic symbols in them. It is a sequence of every known element in the universe arranged by increasing number of protons in their nuclei. Oh yeah, by the way, somebody had asked earlier about string theory, and we do talk about string theory. If you're interested in those discussions, then certainly you should go find the lives and videos on the channel where we have talked about that. Hopefully you'll find many, many live streams and videos that have string theory in the title. So certainly it is there, and we can talk about it again as well. Now, whether am I a proponent? So I do believe that superstring theory, which is a supersymmetric string theory, is probably the best candidate we have for a grand unification theory. But the problem is that it cannot be tested experimentally, and so we don't have experimental evidence that that candidate theory is verified or correct. So hello, Ahmed. Do you believe in space dust? Yes. I do believe in space dust and the fact that the space dust can often scatter light from sources of light like stars, and that space dust scatter different types of light differently. So we talked about that yesterday as well. Hello, Mr. Drew. Oh gosh. Okay, everybody, can we get 100 likes? Do you believe in space dust? Yes, I do. Please do, please do like, share, and subscribe. It's okay. Don't ask me what caused the Big Bang. Come on. You can ask me about what happened 10 to the minus 43 seconds after the Big Bang, but not what happened at t equal to 0, okay? All right, so cosmic nuclear chemistry is a messy business. By the way, I actually worked on this topic myself in undergrad. So I had an undergraduate research experience in nuclear astrophysics at North Carolina State University under Dr. Carla Furlish from Switzerland. And well, she did either her PhD or a postdoc at UChicago. It might have been a postdoc. I think her PhD might have been from Switzerland. Very nice person, and she still works in, well, I should say she is a great professor and educator, but also a nice person. And she taught our astrophysics elective class and grad classes, of course, and such. And I do believe that she still works in nuclear astrophysics. And she discovered one of the processes for making some of these elements, some of these heavier elements that we are speaking of right now. So there are many, many people who have contributed to understanding the processes that lead to making these elements on the periodic table in stars. So like we know that they are made in stars, but there are quite a bit of details in exactly how they're made and what kind of conditions are necessary to make them. And in fact, those are quite different for the different elements. As you can see, with more and more protons in the nucleus, of course, you're changing the type of element. And just real quick, there's this thing called nuclear binding energy. Certain nuclei are more stable than others. And after a while, remember that we also start to add a lot of neutrons in the nucleus as we get heavier and heavier elements. And keep in mind that this is my aside, my addition to the story here that we are kind of reading about. Keep in mind that basically we have the elements up to iron, then we have the elements above iron, and then we have elements that are like heavier than barium, like atomic number 56 and higher. And sometimes we actually know certain things better about the heavier, really much more heavier elements. They would need very extreme conditions. Some of it is called neutron capture processes, because as you can imagine, if you have a nucleus with protons and neutrons, and at some point in nuclear astrophysics, if you're starting to make the nuclei that have a lot more neutrons, then that process is intuitively quite different than the process that would make a lighter element, which of course has an atomic number much less, and also maybe the proton to neutron ratio is more like closer to 1, okay, versus not a lot more than 1. So things like that. So keep in mind that there is quite a bit of diversity actually in the periodic table, and not just the periodic table in what it looks like and all the symbols and all the that type of stuff superficially, but also in terms of how you make those elements, starting from hydrogen all the way to the end of the periodic table. Of course, hydrogen and helium we got from Big Bang nucleosynthesis, but everything above that we've made in stars, we've made in supernovae. When the stars die, we make either in stars or we make during the supernova process, or even in certain stellar remnants under certain conditions. And there are a number of processes. So keep that in mind, that there is quite a bit of variety, okay? It's not a simple process that just makes every element, okay? The periodic table is, of course, much more than just a mysterious chart of 100 or so boxes with cryptic symbols in them. It is a sequence of every known element in the universe arranged by increasing number of protons in their nuclei. The two lightest are hydrogen with just the one proton and helium with two protons. Under the right conditions of temperature, density, and pressure, you can use hydrogen and helium to synthesize every other element on the periodic table. And in fact, that is what we have done in stars and supernovae. Without that, we wouldn't be here, of course, because the Big Bang and shortly after physics just gave us hydrogen and helium. So we could have been in a universe of just that if we did not eventually make stars much later, and those stars started to make the heavier elements. And of course, how did we start to make the stars and galaxies? Because little cosmology tidbit, because we started to clump in parts of the universe and gravitation started to win in certain overdensities of the otherwise smooth universe. And that is also a topic that we talk about quite a bit because it's a cosmology topic. Okay, so a perennial problem in nuclear chemistry involves calculating accurate collision cross-sections, which are simply measures of how close one particle must get to another particle before they interact significantly. Collision cross-sections are easy to calculate for things such as cement mixers or houses moving down the street on flatbed trucks, but it can be a challenge for elusive subatomic particles. A detailed understanding of collision cross-sections is what enables you to predict a nuclear reaction rates and pathways. Often small uncertainties in tables of collision cross-sections can force you to draw wildly erroneous conclusions. The problem greatly resembles what would happen if you tried to navigate your way around one city's subway system while using another city's subway map as your guide. Apart from this ignorance, scientists had suspected for some time that if an exotic nuclear process existed anywhere in the universe, then the centers of stars were as good a place as any to find it. In particular, the British theoretical astrophysicist Sir Arthur Eddington published a paper in 1920. So this is all happening in the 20th century, as well as many other interesting things that happened then. This thing was called The Internal Constitution of the Stars by Eddington, where he argued that the Cavendish Laboratory in England, the most famous atomic and nuclear physics research center of the day, could not be the only place in the universe that managed to change some elements onto others. So little excerpt from that. Do I have a booger? Well, do pardon it. But is it possible to admit that such a transmutation is occurring? It is difficult to assert, but perhaps more difficult to deny, that this is going on. What is possible in the Cavendish Laboratory may not be too difficult in the sun. I think that the suspicion has been generally entertained that the stars are the crucibles in which the lighter atoms which abound in the nebulae are compounded into more complex elements. This is what he wrote. We did not bind ourselves to the formation of helium from hydrogen as a sole reaction which supplies the energy to a star, although... So by the way, this is the thing, right? You might wonder, not only the fact is that the stars are making the heavier elements, because the stars are making the heavier elements is why they're staying alive. So stars are doing that job of making elements or making heavier elements during their lifetime. Some elements also, some things are also made during the star's death. So it's not just the lifetime. During extreme conditions is when the heavier elements are made. But while the star is alive and it's burning, its nuclear reactor is going in its belly and it's making heavier elements out of lighter elements, like what our sun is doing, making helium out of hydrogen mainly. That is also keeping it alive. So if it runs out of that nuclear power, the other main thing in a star, of course, is gravitation. A star is very massive. So if a star kind of runs out of its nuclear power, it will start to collapse under its own gravitation, and that usually will lead to its death. Okay, and that of course also has certain processes that happen then to make some elements as well. But pretty much the making of the elements is also important for the stars. Okay, so we need not bind ourselves to the formation of helium from hydrogen, which is what the sun does, as the sole reaction which supplies the energy to a star. This is what Eddington was saying back then. Okay. Although it would seem that the further stages in building up the elements involve much less liberation and sometimes even absorption of energy, the position may be summarized in these terms. The atoms of all elements are built of hydrogen atoms bound together and presumably have at one time been formed from hydrogen. The interior of a star seems as likely a place as any for the evolution to have occurred. Okay, so the observed mix of elements on Earth and elsewhere in the universe was another desirable thing for a model of the transmutation of the elements to explain. But first, a mechanism was required. By 1931, quantum physics was developed, although the neutron was not yet discovered. So, by the way, can anyone say who? Let's see. We might be naming the person soon here, but okay. Can anyone say when the neutron was discovered and by who? The neutron in the nucleus. Can anyone say when was the neutron discovered and by whom? It was in the 1900s is a clue. Oh my goodness! Correct! Jane, somebody said it. Jane Smith said it, 1932. James Chadwick. Good job, Muggle Chops. James Chadwick. I love it. You know. Hello, Mike Ferguson. Hello, Wigby. Hello, Lord have mercy. AJ. Thank you, guys. Namaste. Hello, Science. Hello, Mike Ferguson. Oh, gosh. Sorry. I pressed a button and it accidentally showed you the stove that's never used here. We need to promote intelligent women. I'm sick of women playing dumb to get stuff for free. I feel like we match the same vibe. Thank you, AJ. It's a great kettle. Here, you can see my kettle again. I know. Thank you. Thank you, thank you. It's a great kettle indeed. I think my mom bought it, so I can't really take credit. Hello, Ricardo. Thank you. This is the kitchen and this is the living room. It's all here. Okay, James Chadwick, that's the answer. We will keep going. We will keep going. Thank you. It's nice to see your chat messages because I took a little break. Have you ever been to Boston? Yes. In fact, I'm in Boston. So, by the way, guys, thank you so much. Oh, you wanna get another question? Let's see. What is the atomic number of the element called molybdenum? Molly being the nickname. Molybdenum. So, oh, thank you. Am I on there? Was I on Rate My Professors? Molybdenum, not Molly, as in whatever other Molly. NC State has some great professors and what a beautiful church next to it. I don't think I've seen been inside the church, but NC State does have a lot of really good professors. I had a ton of really great professors. Thank you, everybody. Molybdenum. Siri told you 13? Oh, now my Siri is starting. Siri, go away. Don't ask you know who, starting with an S. Clearly, they're wrong. Did you really find me on Rate My Professor? I think I was on there at one point. I didn't realize that was still a thing. Okay, I'm actually gonna heat up my hot chocolate again because it's a little cold, and I'll be right back. I'll be right back. Okay. All right. Okay, so I'm back. No, I'm here. Reese, can you like the live? Like and subscribe. Hello, mother of cats. How are you getting ready? I did go for my sanity walk today. Thank you for subscribing. Okay, let me put in the, it's going, how are you? Reese, how's your son? And I see that we have 99 gifts. Could we have an even number? Thank you for joining, Reese. How has it been going? Sorry, I got a bit distracted. my gosh, Talia, thank you. Thank you for the floating heart. Okay, so we will continue. The observed mix of elements on Earth and elsewhere in the universe was another desirable thing for a model of the transmutation of the elements to explain. But first, a mechanism was required. By 1931, quantum physics was developed. So we have spoken about how the 20th century was so very productive with both, you know, special relativity, general relativity, all of that being developed, as well as all of quantum mechanics, which of course became very successful and went on to give us particle physics, and also all these things about astrophysics too happened during the 20th century. So one of the things, by 1931, quantum physics was developed, although the neutron was not yet discovered. And you guys just told me when the neutron was discovered and by whom. So, and the astrophysicist Robert D'Escourt Atkinson published an extensive paper that he summarizes in his abstract as a synthesis theory of stellar energy and of the origin of the elements, in which the various chemical elements are built up step by step from the lighter ones in stellar interiors by the successive incorporation of protons and electrons one at a time, okay? At about the same time, the nuclear chemist William Harkins published a paper noting that elements of low atomic weight are more abundant than those of high atomic weight, and that on the average, the elements with even atomic numbers are about 10 times more abundant than those with odd atomic numbers of a similar value. Hello, Coop. You love dwarf planets, so you must love Pluto, who is a dwarf planet, not a planet. There you go. Harkins surmised that the relative abundances of the elements depend on nuclear rather than on conventional chemical processes. So what happens in the stars is not chemistry, it is nuclear physics, or maybe one might call it nuclear chemistry, but it's basically stuff to do with the nucleus, not chemistry, which has to do with atoms and electrons and such, okay? So, so not conventional chemical process, and that the heavy elements must have been synthesized from the light ones. So you have light elements fusing together, simply put, to become the heavier elements in stars, okay? The detailed mechanism of nuclear fusion in stars could ultimately explain the cosmic presence of many elements, especially those that you get each time you add the 2-proton helium nucleus to your previously forged element. These constitute the abundant elements with even atomic numbers that Harkins refers to. So the even atomic numbers, or the even number of protons, basically you can just think of it as a bunch of 2-proton heliums doing that, right? Including, but not limited to somebody's, I think some people were, some people mentioned about carbon being their favorite element. So yes, Adam is doing a great job, Reese. So you can sit back, relax, and enjoy the flight. You need my face wash routine? I don't think I currently have a face wash. I mean, I did, but I ran out. So thank you for reminding me. I do have to get some face wash from the Indian grocery store. I usually get face wash there. But I think, yeah. The hot cocoa is my secret. The neutron, discovered in 1932 by the British physicist James Chadwick, while working at the Cavendish Laboratory, seems like an important place, plays a significant role in nuclear fusion that Eddington could not have imagined. So this is where some of the more heavier elements, like the heavier heavy elements. So think something especially like barium and above, which barium, I believe, is atomic number 56. Somebody could confirm that. Look it up. those elements that are significantly heavier than iron, this especially will require, turns out, the neutron. So, you know, the neutron is neutral. It was discovered kind of later, and without discovering it, people might not have known its important role in those processes, okay? As we will see here. To assemble protons requires hard work because they naturally repel each other. And what, okay, quiz question. What is the force responsible for the repulsion of protons from each other? What is that fundamental force? Everybody, put it in the chat. Sorry. Okay. So hello, James Garcia. Inertia. Snokumoi. I got it. Barium atomic number is 56. Good. Electromagnetic. Yes. So remember, guys, that the electromagnetic force has both attractive quality as well as repulsive. Two like charges will repel each other and two opposite charges attract each other. So Derby Eternal has won again. We will come to the strong nuclear force. So Lord have mercy is in the ballpark. You are on the right track here. Magnetism, somebody said, so that is fine as well because electric and magnetic fields are interchangeable, and together the topic is called electromagnetism. What am I saying? Electromagnetism. I was trying to say anyway. Somebody said electromagnetic force, so that is correct. Also, we can say electromagnetism or pretty much electric, magnetic. Those are all interchangeable into each other anyways. So all correct. Barium atomic number is 56, says Adam. Very nice. Thank you, Adam. So anybody that said those are all good. Oh, thank you, Derby. Sent a floating heart. My nose. The channel prior to this disturbed me mentally. Oh, well, you are here now. It's a safe space, and can we get 100 likes? So, two protons both have positive charge. So, two protons will do what? Repel each other according to the electromagnetic force. So now there are four fundamental forces of nature: electromagnetism, strong nuclear force, weak nuclear force, and gravitation. Now, of course, long story short, gravitation is not explained by particle physics. In the realm of quantum mechanics and particle physics, especially, we talk about these four fundamental forces. But for gravitation and its understanding, we actually rely on general theory of relativity and whatnot. I mean, really just GR. We just rely on general theory of relativity. We don't have a better explanation for gravitation anywhere else. Too bad and so sad. But when it comes to the protons, remember, of course, that they actually are, we're going to find out that they're affected by the strong nuclear force, like somebody pointed out. I think, Lord have mercy. Said about strong nuclear force. Sorry, I just read a comment.